It's a real privilege to be back at ACHEM. I was just talking with Gary and Michael and reminiscing a little bit. My first exposure actually to this field was an AMPS meeting, the predecessor to ACHEM. Thanks to Gary, I think I was invited as a weirdo university professor. I'm now just a weirdo. I'm not a university professor anymore, but it was a wonderful introduction to the field, and I've really enjoyed the mentorship that I've had from many of you over the, well, from '76 to 2014, almost 40 years. Hard to believe. It's scary to even say that. So I very much appreciate being here. What I'd like to share with you are some thoughts, and to try to do in less than 2 hours a complete job about the emerging understanding of the immune system as it relates to chronic disease would be, even for me with my rapid speaking style, would be impossible. So I'm going to try to do a little bit of cherry picking and try to pick out some topography in this field that I hope might provide some news to use for you as it relates to clinical insights in this complex situation that we call chronic inflammation and chronic inflammatory disorders. This is a very rapidly advancing field, and I don't think anybody, even the strongest bibliophile, could really keep up with the rate of all the publications that are coming in across so many different fields that intersect in this area of inflammation. So again, with some degree of implied hubris, I'm going to move into this with the fear that I'll either offend one of you or you'll feel like I've missed some critical element of the talk. So I'll apologize before I even begin, knowing that it probably is not going to be completely satisfying. Where I want to focus my energies, however, knowing that inflammation is this huge elephant in the corner, is on the emergence of this chronic metabolic inflammation that is associated, some people call it meta-inflammation, maybe you've heard that term, that relates to disorders that are surrounding cardiometabolic disease. And cardiometabolic disease sounds a lot like it's cardiology, but because we put the term metabolic after cardiac, it really spans a whole array of different ICD-9s. In fact, I did a little partial list once of the ICD-9 codes that one could put under the broad heading of cardiometabolic disorders, and it's literally several hundred different diagnoses. So this is a unifying theme, this concept of cardiometabolic disorders, and it directly relates to the emergent understanding, and the etiology relates to the emerging understanding of what we call metabolic inflammation. So these are all intimately woven together in this new language of 21st century medicine. And I just threw up some terms that, I could have put hundreds of terms on this slide, but just some terms to kind of give you a Rorschach identification with what we talk about when we talk about that of metabolic inflammation and cardiometabolic disease. And you'll notice that it has prominently an immune component associated with it. I put the macrophage in a bright color there to remind us that there is this both innate immune system relationship to cardiometabolic disease, and there is also a acquired immunity component. So that would be both a T and a B cell component. And we're going to talk a little bit about the origin of those and what that means. I've tried to codify some of this in the recent book that I published in June of this year, which is really kind of a walk down memory lane for me of the 30 years that I've been fortunate to be involved actively both in research and in the development of this field. And some of you know that if I was to have said if someone asked me, in fact my kids have asked me, Dad, all this traveling you've done over the years, what would you say is the principal thing that you've left in your wake? And I think the principal thing is this concept of systems biology in healthcare. And when I first started talking about this in the 80s, it was really considered kind of way out there, and I think very few people understood what I meant when I was talking about a systems approach to healthcare, because we were still very locked into the differential diagnosis and the primacy of disease and this kind of siloed vision of different subspecialties of medicine, and they each had their own drugs, and they each had their own diagnoses, and they each had their own country clubs, and never the twain shall meet. You didn't crosstalk. But over the years, this concept of systems thinking in medicine has really started to gain traction, and it's a very rapidly rising field. In fact, if you do PubMed search on systems medicine or systems biology, it's a pretty flat line growth of publications up until about the middle to late 80s. And then it starts moving up kind of this exponential growth. And in the 90s, it just really took off. It's the doubling time of information in this field is less than 2 years. So it's a very active area of trying to understand the interconnectedness of physiological processes that we later then diagnose or call a disease. In the functional medicine model, which we kind of birthed in 1991, we kind of codified these different, what we call core physiological processes, into 7 buckets. And the reason we chose 7 wasn't that there's some universal divination to the number 7, but when we started to sift the literature that was available back then into piles, and actually that's the way we did this. We had several thousand articles. We met in Victoria, Vancouver, British Columbia, kind of in a whiteboard meeting, about 30 of my colleagues and I, and we started sifting our articles into different piles that suggested that they would be involved, no matter what they said in the title, with a certain topic. And those topics that we eventually ended up with were these 7 piles. And we started off with more piles, and then we kept consolidating until we got to a core, what we consider lowest common denominator. And those 7 piles are what we call the 7 core physiological processes. Now, one could argue, say, there's more or less. I don't want to get into the debate. What I want to talk about, however, is that once we get to these fundamental mechanisms that underpin disease, what we call the disease is less important than understanding where it came from. That's the fundamental mechanism. So I don't want to get hung up on whether it's 6 core processes or 10 or 3, but the construct is that there are basic core physiological disturbances that map themselves against a whole variety of different chronic illnesses. And so those 7, just to remind you, which I just describe in more detail in the book, include this assimilation elimination area, which is obviously gastrointestinal related, detoxification, which we often think of as hepatic function, but it appears in many other cell types, that there's these phase 1, phase 2 detoxifying systems, immune defense, which I'm going to speak to some great extent over the next hour or so, cellular communication, which are basically these molecules that are involved in communicating at a distance a message that's signaling from one site in the body to another, the cellular transport, and we think of things like the lipoproteins or glucose transport as being very important, and there are defects, in dyslipemia that really relates to apolipoproteinemia. So we talk about LDL carrier proteins or HDL carrier proteins and how those are related to transport activities, getting something from one site where it's made to another site where it's used. And then energy, this is what we all know as mitochondrial oxidative processes. And actually, I'm very proud to say that when I look back, my first lectures on mitochondrial function were at ACHEM back in the early 80s when we were starting to do work at the Pauling Institute on bioenergetics and the relationship to nutrition. So this field has been emerging very rapidly, this whole bioenergetic field and its relationship to free radical oxidation and apoptotic processes in cells. And then lastly, structure, when of course Pauling was the great believer in structure function. You get one right, the other gets right, and they're interrelated intimately. And so we think about things like the skeleton as this thing that's dead over in the corner of an anatomy lab, but actually it's very live, and it's pertaining to a production of white blood cells. It has all sorts of cell signaling molecules it produces that interface with the GI tract and with the beta cells of the pancreas. So again, structure and function intimately involved. So those are the 7 core physiological processes. Now I'm going to try to relate all of these in the next discussion to this concept called metabolic inflammation, and how that relates to disturbances among these 7 different core physiological processes. That's the strategy of my talk. So I hope you get where I'm heading here, and we can walk down this road together. So if we look at this chronic systemic inflammation, you notice that, again, it appears in the phenotype of disturbed function of many cell types. Now, this is an important construct that I hope I'm not missing here, and that is, often when we study cytology or histology, we thought of a specific cell that was damaged by a certain pathological process that was unique to that disease. So each disease had a certain histology or a certain cytology associated with it. In the case of chronic metabolic inflammation, however, you notice it cuts across many cell types, and they're not really, under the microscope, most of them are not significantly different in their phenotype or their architecture from a normal cell, but they're functional effects, meaning the way the genes are being expressed in those cells under the state of chronic metabolic inflammation is different. So they have a functional difference more than a structural difference that you can see under the microscope. And I think this is an important differentiation, because Some people might say, if you can't see it, we don't believe it. And then the question that we would ask is, well, what are you using to see it? Because there are different ways to see. You can see with your naked eye, or you can see with an X-ray, or you can see with a nuclear magnetic resonance spectrometer, or you could see with an autoantibody test. I mean, there's many different lenses you can use to see things. And what we're talking about here as it relates to adipocyte change, immune systems change, neuronal change in the microglia, the brain being the brain's immune system, or the systemic increase in cytokine concentrations that are reflective of chronic inflammation, that these cut across many different cell lines and different cell expressions into tissues, organs, organ systems, and clinical symptoms, none of which you can see easily under the microscope, right? So there are other levels of dysfunction that are occurring that are kind of, depending on where you look, you might say they don't exist, but they do look if you ask the right questions. Okay, so that's the model.